this is, in fact, an even function. So even functions, you plug in a negative, you get the same out. It has symmetry of the y-axis. Odd functions, on the other hand, all right, we have symmetry of the origin. So let's check these out. Examples of odd functions. So that means, algebraically, if I plugged in a negative x value, I should get the opposite of all my values. And actually, this is not an odd function. I'm sorry, I'm going to erase that. Make sure I have, yep, this is. Okay, it should just be negative cube minus x. All right. We have that right there. Oops. So I'll erase that. I apologize. The negative x, plug that in there. All right, so we take that cubed, and we have the opposite. Turns out the opposite of x cubed, and this turns into positive x. Notice how each one of my terms, okay, right here, is going to be the opposite of what it began with. All right? And so, therefore, this is an odd function. All right? This is an odd function. Okay? In the same way, if I go over here for a little more difficult one, okay, I do k of x. Now, this one has a square root. And if I plug in a negative, I'll have the negative x on the outside and the square root of negative x squared plus 5. Now, be careful with this, because how would this be the opposite? Well, the opposite means that all the values will be negative. Well, when you have a square root, well, obviously, a square root will never make any negative values, and it shouldn't. And if you notice inside the square root, all the values stay the same, which they need to be. But on the outside, this function turns to the opposite. Therefore, because it is all opposite values from where we began with, compared to this function, this is an odd function. We can identify this, more specifically, is if we graphed it. When you graph this function, you can identify that, yeah, this graph has symmetry over the origin. What I have over here, and the opposite is going to be over here. So we have a positive, then we have, plug in the negative, everything's going to be negative. It has symmetry over the origin. You can also see that when I plug in like 1, I got 2.4495. When I plug in negative 1, I got the same value, but it's opposite. That is what we mean by symmetry of the origin in odd functions. Is that when you plug in the opposite, you get the opposite output out, unlike even functions. All right. So that is how we can determine odd and even